No, but this is, yeah. So 7.1 exponential growth and decay function. So an exponential function is basically, let's go to the pen. It's a function, it's when the variable is an exponent. I know, you never would have thought that, would you? So actually the parent function is f of x equals 2 to the x. What's an exponent? An exponent is like 2 to the 4th power. That's your exponent. You follow me? That's an exponent. All right. It's a variable. Actually, I think variable only has one r. But I do it with 2 all the time. I don't know why. Let's see.
Patent?
Exponent. Parent. Yeah, I know. I can't write. What are you going to do?
Parent. Oh, parent function.
Parent function. Okay, so your parent function is f of x equals 2x. That is the most basic form. All right, an exponential growth function is when b is greater than 1, okay? And your b value is basically this thing right here. Like in that case, your b value is 2, okay? But so the basic form would be y equals a times b to the power of x. So whatever is being raised to the x, that is your b value. So for example, 4 to the x is a growth function. 1.2 to the power of x is a growth function. 9/4 to the power of x is a growth function. Because all 3 of those are bigger than 1. Cool? All right, the growth factor, that's it's your b value. All right, so they asked, what's the growth factor? Well, for the first one, if you want a growth factor of 4, that's that one right there. If you want a growth factor, every time I write that I think girlfriend, but whatever. If you want a girlfriend of 1.2, whatever the heck that means, that's your growth factor right there. Scale of 1 to 10. All right. Those are your growth factors. All right. An asymptote. We've talked about asymptotes before. Asymptotes is a line. The graph approaches APPROACHES. I still can't write it out right. OA. But doesn't touch. All right, it's going to get infinitely close to that line, but it'll never touch it or never be in the same spot as that line. I'll put it that way. It's kind of like leaning up against the wall. You can get infinitely close to it, but you cannot be in the exact same place as the wall is. You would have to start shifting atoms at that point, but even then, the wall would move, and you would not be where the wall is.
Or you could be like Flash.
I like the Flash. Yeah, the Flash is something else. We're not talking about the Marvel world here.
Okay, no. DC though, but yeah.
Whatever, you're right. It is DC. You're absolutely right. But here we go. So if I were to graph something with an asymptote, so in this case, the asymptote is going to be, most of the time, it's going to be right on that x-axis at y equals 0. The ones we're talking about today are going to have asymptotes there, but there are others. And your graph is going to come in like this and then swoosh down and get really, 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 really close to it, but not actually touch it. It will be like 0.00000000001. And then it will get closer than that. I mean, this is what it is. Cool. And the way they look, they kind of look like, you ever been to Six Flags and rode the Mr. Freeze?
Yeah.
That's kind of what it's like. You start off level, and it shoots you straight out, and then it curves up and go up. You do kind of get whiplash from it. The Titan, you used to get whiplash. Okay, the first year they opened the Titan, you notice how when you start those corkscrews, it brings you and it kind of stops you? Yeah, the first time they did it, they didn't stop you there. They just kind of tapped you and let you keep on going almost full speed. Yeah, you almost blacked out. It was fun. It was
Why'd you
awesome.
stop it now?
Because too many people blacked out.
What? I want to black out.
Yeah, I didn't, but it was fun. Anyways, so an exponential decay function. Okay, an exponential decay function. That's when b is between 0 and 1. That's when your b value is between 0 and 1. Now, your b will never be negative. If it is, you have a negative base, it is no longer an exponential function. Yes, the exponent is a variable, but it is no longer an exponential function. All right? But b is between 0 and 1. So, for example, y equals 1/2 to the x, or 0.3 to the x. Those are all less than 1. All right? Negative 0.2 to the x. You can't do that one because it cannot have a negative number in there. Okay? And again, your decay factor is simply your b value. But in this case, it's when it's less than 1. So it's not a growth factor anymore. It's a decay factor. So that's a b. That's a d. There you go. So your decay factor. If the other one is your girlfriend, this is your dying friend, I guess. That's kind of morbid. So that's your growth factor, or you got a decay factor of 0.3. Is it not writing?
Yeah, no. Something B value.
Stupid thingy. All right, well, let me pause this real quick. All right, so we're back in business. There's your decay factor. There's your growth factor. No, we're not done. You know better than that. All right, so that's basically what we're talking about. We've got growth functions. We've got decay function. It all has to do with 1. If you are bigger than 1, what are you, growth or decay? If you're less than 1, you are?
Dinosaur.
Can you be negative? No. Okay, so those are the biggest 3 takeaways from that section. All right, turn the page. Let's keep rolling. Your parent functions, or your basic functions. I'm actually going to combine these 2 pages a little bit, and I'm going to change the formula they give you. All right?
Okay.
I'm going to tell you that we're going to use y equals a times b to the x. All right? And in all cases, a is your y-intercept, or your start. Whatever your beginning value is, that is your a value. So in this case, right here, this y-intercept is 0, a. That is that point. Okay, that y-intercept is 0, a. All right, but a lot of times your a is not there. Well, what's the coefficient if we don't write anything? Like, if I just have an x, what's the number in front of it? 1. All right, so the ones we're dealing with today, a lot of them have a 1 out front, and that's okay. That's why they started off with a 1 right here. All right, your other one, this one right here, is not just 1 times b. It is 1, a times b. It's that scalar, that starting point, times whatever your b value is. Okay? And this is for if you've got growth. If it's growth, this is generally what your formula looks like. Okay?
So you like A to the...
Like if you had y equals 2 times 4 to the x. 2 times 4 is 8, so it would be at the point 1, 8. Does that make sense? Well, your a is 2, your b is 4, 2 times 4 is 8.
What about the exponent?
Don't worry about it. It's not that your expo. I'm serious. Your exponent is not part of this. It just says take your a value, take your b value, and multiply them together. That's all you gotta do. All right. Your b. This is the same thing. Okay. The only difference is your b value is a decimal. It is between 0 and 1, or a fraction. So, but this point down here is still 1 times whatever a is. This point right here is still, I'm sorry, not 1a, it's 0a, I'm sorry. And this point right here is 1a times b. All right, well, they're gonna work you into the whole a times b eventually anyways. I'm just getting you to where you already kind of know about it, okay? And then last but not least, your domain and range. All right, your domain, does this go right forever? Yeah. Does it go left forever? Yeah, it's going up, but it's still going to be going left. So it is what?
All real.
All real numbers. Your domain is all real numbers. Your range, in this case, your range is y is greater than x because that's where your asymptote is. Your asymptote is right there. Your asymptote is y equals x. Y equals 0, I'm sorry. And it's everything above that. Sure. What are you doing? What's going on? Oh. Cool. If we flip it, then it's y is less than 0. All right, so that asymptote is going to move eventually. But that's what we've got. All right, turn the page. Let's start graphing a few of these.
Wow.
All right. First things first, tell whether the function is growth or decay. So letter A, is that growth or decay? Why? Good, it's growth.
What? Growth?
Because B is greater than 1. Well, what's your B value in this case, Henry?
2.
2. Is 2 bigger than 1?
Yeah.
Then it's growth.
I put my because like that.
BC?
Yeah.
Yeah, BC period. That's because BC is an abbreviation for because. See, there are some text speak that are actual acronyms or actual shorthand. All right. All right. So in this case, we'll talk about your A value, your V value. We already said your B value is what? 2. In this case, what's your A value? What's being multiplied out here? 1. That's why it's not written. Okay? So you automatically know, remember, when x is 0, y is A. When x is 1, y is A times B. Those are the two you already know. You don't have to calculate anything, really. So here we go. Well, I don't know, you might, but... So when x is 0, what is y?
Mr. Hunter, y A is 1.
Is there anything multiplied out front, Henry?
2.
No, it is a 1. It is 1 times that. So...
So when it doesn't have any number.
So if you had something like this, y equals 4 times 2 to the x. Your A value is 4. All right?
So you just...
There's nothing there, so it's just a 1. So in this case, your first point is at 0a, so it's at 0 what? 1. I know. When x is 1, it's at 2, because 1 times 2 is 2. So let's start graphing. 0, 1, 1, 2. Cool? Now we need a few more points in that. So let's plug in a few. Let's take 2 and plug it in for x. Okay, so 2 to the second power is what? 4. So when x is 2, y is 4. Cool. All right, let's do another one. We still got room to put on the graph. So what about 3? When, again, plug that in for x. When we got 2 to the third power, what's 2 to the third? 2 times 2 is?
4.
Times 2 is? 8. So when you got 3, when x is 3, y is? 8. Cool. So we're starting to get an idea of what this thing looks like. And your horizontal asymptote, until we tell you otherwise, your horizontal asymptote is at y equals 0. It is right there at that x-axis. Which I think we'll deal with that in either the next section or the one after.
Why is it A for 3? It doesn't should be 6.
I don't know. She said nothing that concerns me.
What?
When I
Or
said
number 3.
For this one?
Yeah, it doesn't just be 6.
2 to the third power. We plug in a 3 for 2. 2 times 2 is 4 times 2 is 8. Third power. It's not 2 times 3, it's 2 to the third. So your graph looks like this. All right. Like I said, it looks kind of like the Mr. Freeze ride. Cool. I know, riveting stuff. This will change your life. All right, letter B, same idea. Letter B, is that growth or decay?
Decay.
Why?
Because it's going, it's dividing.
Good, it's decay. Because B is less than 1. All right, so let's list out your A and B values. What is your base? What is your B value? 1/2. 1/2 is being raised to the x, so B is 1/2. Okay. What is your A value? What is it being multiplied out front by?
1.
1. There's a 1 right there.
Yes.
That was rude. So here we go, XY. So when x is 0, remember it's 0A. So when x is 0, y is 1. Good, because your A value is 1. When x is 2, your y value is
4.
1.5.
when x is 1, it's A times B. What is A times B?
1 and 1/2.
That's 1 plus 1/2. What's 1 times 1/2? 1/2. 0.5.
I said.
No, you said 1 and 1/2. Like 3 times. So we got 1. Oh, it's not 2. Why did I put a 2 right there? I'm sorry. That may have thrown a few people out. So that's a 1. You'll survive. So we got 0, 1. And I'm going to zoom right here. 2 and 1/2. Because I can't. I'm going to zoom in a little bit. All right, so here's the deal. So if I keep going to the right, this is just going to get lower and lower, and it's really going to tell me a whole lot about the graph. These are going to get really, really small. Okay? So let's go to the left a little bit. Sure. Let's take -1. All right? So let's take 1/2 to the -1. Come on, y'all. What does a negative exponent do?
Change the sign.
Does what? Doesn't change the sign. What's up? Yes, you can. You can have a negative base. It does do something in a different. What goes a different way? I think you're on the right track, but it flips it. It means, hey, we need to flip the fraction. It's on the wrong side. So instead of 1/2, it's 2/1, which is just 2. Which you don't have to write through the 1. So when -1 is x, y is 2.
I got a question. Why the first number is always 0?
Because I just got to start with 0 because I know my A value. I'm just picking points in a lot of ways. You follow? When I'm graphing, I'm picking points. You can pick whatever you want, but I'm just picking ones that are on the graph. So let's do another one. Let's do -2. So if I got 1/2 to the -2, okay, the negative does what? Flips it. It tells you to flip the fraction. So I got 2 squared, which what's 2 squared? 4. So when x is -2, y is 4. All right. Let's do the next one. Let's do one more. -3. So if I've got 1/2 to the -3rd. I don't know why I said it that way. Whatever. It becomes, instead of a 1/2, it becomes a, not a 6. What's 2 cubed?
Wow. That's impressive.
Well, you don't be talking about it.
Mr. Hunter, where did you leave the Wow, Daniel.
I didn't leave them anywhere. They're not here. They're using them for testing tomorrow. All right, and your horizontal asymptote is still at y = 0. Right there. So you're going to have a graph that comes in real low, hits those points, and shoots up. Cool. How are we doing with this? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. It's not bad. It's a good bit of information, but it's not bad.
Always a working.
All right, I'll kind of leave that up there a little bit. Number C, here's what I want you to do.
Number C?
Letter C. I want you to tell me if it's growth or decay. I want you to find the A value and the B value. And then I want you to graph it.
Oh, this thing looks like a banana. Dude, I messed up banana. It's like a messed up banana.
And graph it. Okay?
Zero always to one.
So you get something that kind of looks like that. Now, did you have to do this -1 down here? Okay, let me ask you this, Daniel. Did you get these four right? These two right here?
Yep.
Did you get the first one?
No.
I did.
Okay. We need to start figuring this part
Yeah,
out.
half of them.
So it's 0A. What's your A value in this case?
1.
1, so it's 0, 1.
So, if it's just y equals any number, it can be 1.
It's going to be 1.
But if there's parentheses, well, no, it doesn't even matter, there's parentheses, it's still 1.
Give me a second.
Cool.
How about this one right here?
That's 25.
A is 25, B is?
0.85.
Okay, does that help you see the difference? All right, cool.
No, I just didn't know what to put on the table.
Oh, I see what you're saying.
Like, I don't know why it was 1, or why it was A value.
It's just, that's just how it is. Think of that as just the rule. Does that make sense?
So you know, when you get 4, but you square it, what do you square it?
Why do I square it? I plugged in 2 for x. If I plug, like, let's put it this way. If I plug in a 0 right here
Where?
for x, 4 to the 0 is 1. If I plug a 1 in right here for x, 4 to the 1 is 4. If I plug a 2 right here in for x, 4 squared is 16. If I did a 3, 4 to the 3rd power is 64. Your x values are just inputs. If you don't remember the rules, you can always just shove it in for x and see what you get. No shame in that. All right, we're not going to graph the rest of these, but real quick. Letter D. Is this growth or decay?
Decay.
I don't like to repeat myself.
It's decay. What about E? Is that growth or decay?
Decay.
What about F?
Decay.
It's growth. It's 1.5. It's growth. What if we gave you 7/3? Is that growth or decay? That would be growth because 7/3 is bigger than 1. If it was 7/3 to the x, I'm sorry. 7/3 to the x, that would be growth. Cool? All right, here we go. Exponential models. All right, they talk about these as if they're two different models, both a growth model and a decay model. I would honestly tell you they're the same thing. Okay, they really are. There's one subtle difference. So if I got y equals a parentheses 1 plus or minus r to the t, that is the model. Okay, here's why they broke it into two. If it's growth, which one of these do you think you're going to use, the plus or the minus? Oh, y'all are brilliant. If it's a decay, which one are you going to use? The minus, exactly. It is the exact same formula. But you know, if it's growth, it's above 1, right? So it would be 1 plus something. If it's decay, it's less than 1, so it would be 1 minus whatever your percentage is. Cool. So if we're building these, that is the model that we're going to use. And so A is still your start. R is your percent change. And T is time. And T in this case is time. Now your percent change is as a decimal. When you use it as a decimal, when we talk about it as a percentage. But those are what those variables stand for. All right? So here we go. Letter A. If the value of a car, Y, in thousands of dollars, can be approximated by the model Y equals 25 times 0.85 to the T, where T is the number of the years since the car was new, it says tell whether the model represents exponential growth or decay. So in this case, what is your B value for letter A, for this one? Ooh, what's your B value for this one right here? 0.85. So is it growth or decay? It's decay. Because B is less than 1. In this case, what is your A value? In this case? 25. So how much was this car in the beginning? So if the starting point is 25, how much did this car cost new? Well, 25 what? Is that what it says right here? In thousands of dollars. So it's 25 what? $25,000. There you go. Cool. All right, then it says identify the annual percent increase or decrease in the value of the car. All right, so to identify how much you're going up or down, what we're basically going to do is we're going to go 1 plus the R. We're just going to take the plus, all right, and we're going to set it equal to your B value. All right, so here we go. We're going to go 1 plus R equals 0.85. And what is the only thing you have to do to solve this? Subtract what?
Mr. Hunter, but if it's the guy, it doesn't should be less.
I'll show you why in just a second. You're right, but I'll show you why in just a second. So it's R equals, what's 0.85 minus 1? Yeah. Negative 0.15. So that is a 15%. Is it a 15% increase or a 15% decrease? Decrease. Whatever. She's actually paying attention.
Hey, how you know that the it's decreasing the percent?
Well, your R value, is it positive or negative?
Negative.
Negative, it's going down. So here's what's going on. You asked why did we use the plus instead of the minus. Here's why. If I did R1 plus negative 0.15, that's my R value, right? Don't write that, or just watch it. If that's my R value, what happens to these two right there?
Negative.
It becomes a negative, so that's really 1 minus 0.15. Does that make sense? That's why it's like that. Is it mine? Yep, it's mine. It happens. Don't worry, I'm not that popular. All right, last but not least, it says estimate when the value of the car will be $8,000. So if y is the value of your car, stop. All right, if y is the value of your car, and we're looking for when it's $8,000, what are you going to plug in for y? We said this was 25,000, right?
Yeah.
So what are we going to plug in for y? 8. You said 8,000, and you said 25 3 times in a row.
You're tripping, bro. You said plug in 25.
You did. You totally did, dude. So here we go. So we're going with 8 equals 25.85 to the t. And when they say estimate this, we're going to talk about how to actually solve this later on. But this essentially, we're just going to start trying things until we get what we want. So let's start here. Let's make it a little bit simpler. Divide by 25. Somebody take out a calculator, aka your phone, because we don't have calculators right now. What's 8 divided by 25?
It is 0.32.
0.32. And on the right, you're left with 0.85 to the t. Okay? So what they want you to do is just start trying values like 0.85 to the squared, 0.85 to the third, 0.85 to the fourth, 0.85 to the fifth, 0.85 to the sixth, 0.85 to the seventh. And I'm just going to go ahead and tell you, because we don't have the calculator to do that right now, that if I were to plug in a 7 right there for t, that would give you 0.3205 ... forever. So it's not quite right, but it is what you need. So in 7 years. That's why it's an estimate. It's not perfect, but it's close. Another way to do that would be you could stick this part into your y equals and just check your table. See when you get that point. That's fine too. Cool. But that's what you have to do for that. So let's build a few of these. Let's build another one of these. Letter B. First things first. Here we go. The value of a car in thousands of dollars can be approximated by that equation, where T is the number of years since the new car was new. First things first. I want you to tell me, how much is the car to begin with? What is the starting price?
31.
31 what?
$1,000.
$31,000, because it's in thousands of dollars. Good. Then it says, tell whether it represents exponential growth or decay. Take a second, don't yell it out. Write down what you think.
If it's decay or...
Yeah, tell me if it's growth or decay. All right, which one is it? Decay. Why? Good, because B is less than 1. Or should I say between 0 and 1. Letter B. Oh, wow, this has got doubles. It's got I's and A's, 2's and B's, 3's and C's. Whatever. Identify the annual percent increase or decrease. I want to see if you can do that. Follow the model from above. Use this little guy from above. And see if you can find the percent increase or the percent decrease. Okay? Take, I don't know, 30 seconds. See if you can do it.
1 plus R equals B.
Yep, that would be the formula you use. And go from there.
How do you take the percent?
Good. It's an 8% decrease. How did I get the percent? Well, okay, so you got an R. Did you get 0.08? Okay, remember to go back and forth from the decimal to percent, you just move the decimal point left or right 2 spots. Or you can think about multiplying by 100 or dividing by 100.
So you just move the decimal 2 points left.
No, 2 points to the right. Think of it this way. If I want to go to a percentage, if I want to go 2%, I multiply by 100. If I want to go to the decimal, the smaller one, I divide by 100. Does that make sense? It's another way of thinking about it if moving the decimal point doesn't work for you. Here's one more way to think about it. The word percent is literally per cent. Anybody know what cent means? It means 100. That's why a penny is called a cent, because there are 100 of them in the dollar. So it is literally per 100. That's why 5% is 5 per 100. Straight up what it is. Another way to think about it. All right. Last but not least, and we'll call it a day. Estimate when the value of the car will be $9,600. All right. So follow your model from above, plug in your equation, and at least get to this point. If you can figure out how many years it takes, great. But if you can get to this point, I will be happy. Cool?
We put 96 or we put just a 9? Is it 9 point?
Oh, that's a good question. What would you put here?
9 point.
Would it be 96 or 9.6?
9.6.
9.6. It's in thousands, right? Mm-hmm. So $9.6 thousand. You're absolutely right.
9.6.
Why? Yes, because remember this is in thousands.
Okay.
So it's 9.6 thousands. All right, cool. Go for it.